Let's take a look at probability with dependent events. Now, probability, if you remember, is just the chance that something will happen. And we can look at that as if it was a fraction, like a 1 out of 3 chance. It has to be random, and that's really important because if it's not random, then it's planned and it's not left to chance. There are two different types of probability when we're looking at scenarios when we put multiple events together. Independent events would be like a coin flip where every single time you go flip the quarter, it the first coin flip doesn't impact the second coin flip. There's no change. But on dependent events, this is the new part we're going to do here. The first event has a way of changing everything for the future events there. So let's take a look at this. What is the probability that you'd reach into a box and select a red dodgeball, not put it back, and then reach right back in and get a blue dodgeball? So let's watch this scenario play out in live action here. Get the red dodgeball, throw it, miss, go for the blue dodgeball, hit them, and then the person get up and pretty much be a little bit annoyed with you because you nailed them. Okay, so going back to the beginning of this scenario, what was the probability that you could reach in and grab that red dodgeball? Well, there are 8 total balls in there, so that would be the bottom number of our fraction 8. But how many of them are red? 3 of them, right? So it would be a 3 out of 8 chance. So, you reached into the ball pit, you threw it, you missed, so it's not going back in the box. What is the probability that you would then grab a blue one? And this is where I'm hoping you can see that finally, yes, grabbing that red ball and not putting it back into the box has changed the scenario. It has impacted the second event because yes, there are 2 blue dodgeballs that we can get, but there's only 7 total balls in there. And so it had a huge impact of pulling out that red dodgeball and not putting it back in. And so, then you get the second dodgeball and hopefully you hit the person. If there was a third event and we said, hey, what's the probability that you would get a green ball? It would be 3 out of not 7, but out of 6. So that's what makes it a dependent event, is where it starts to change the total number a lot of times. And you just have to be aware of it and you have to imagine yourself in the scenario. Now let's play this out further. We're not quite done yet. We've just got the individual probability for each event. We want to know what's the probability that we would get red first and blue second. And so what you have to do is multiply these 2 probability events together. 3 times 2 would be 6. 8 times 7 is 56. That means there are 56 different scenarios that could have played out drawing these 2 dodgeballs and not putting them back in. But there are 6 of them that would happen out of those 56 where you'd get red first, blue second. But I'm still not too happy because we can simplify it, and that's a huge issue a lot of you guys are having trouble on, is not simplifying your fractions. Really, we could simplify it by dividing it by common factors, and we would get down to 3 over 28. So there's your answer for that scenario. Let's take a look at this one. What if there were 5 different teams that had to make a presentation? And so we took their numbers, we put them in pieces of papers, and we put them in this top hat to draw them out. What's the probability that team 2 goes first and then team 4? So we could write the question like, hey, here's probability of team 2 goes first, team 4 goes second. If we reached into the hat and we grab that 2, you know what I'm saying? Um, there would be a 1 out of 5 chance of grabbing the 2. So let's just imagine that we've grabbed the 2 and we pulled it out of the hat. What's the probability of getting number 4? Well, there it is. We're grabbing it, but it'd only be 1 out of 4. Okay. And so the first event and the second event, they're dependent on each other because the 2 is not thrown back into the hat. And that's what we mean by saying they're dependent events. Um, Multiply them together and you'd get 1 out of 20, and there's your answer for what's the probability that team 2 will go first and team 4 go second. 1 out of 20 chances. Okay, very slim, about a 5% chance. Um, Here's the last one I want to work on. Gary has a bag of marbles, and so it's got 8 marbles total. One's red, 4 blue, 3 green. That's the color mix-up. Okay. What is the probability that Gary can randomly draw a green marble, not put it back, and then a green marble again? So this is how you would write out your question there. P equals green, green, what's the probability of green followed by green? We know that there are 3 green marbles, but there are 8 total to start with. But after you pull that one green marble out and you don't put it back, well, there's only 2 green marbles left, and there's only 7 total. So we could go through and take a look at this scenario if you need to. If they don't give you a diagram, you can go make it. Here's the 3 out of 8 scenario, right? That's how we got to the first one. But look what's in there since we didn't put it back. There's only 2 out of 7 left. And so that's what I'm wanting you to see, and you can draw that out on paper if you need to. Now, we're not done yet. We still need to multiply these two probability fractions together, and we'd get 6 out of 56 again. And don't forget to simplify. It'd be 3 out of 28.